Hi, Geometry. Something happened where it stopped recording, so I'm not sure what's going on. It's real windy out, but who knows. I only started up the warm-up, and we were doing 10.6. Remember 10.6 we're finding segment lengths? Last section we were finding the angle measures, so now this is the segment lengths. So I can find segment lengths in circles, and I can use them in astronomy. You know, how far is a star away or a planet? So I'm going to just start off. Just going to cover that up so it's not too confusing. Remember when you're solving a quadratic, what two values multiply to get 3, but then we'll add up to get a 4. That would be 1 and 3. Now when we're solving, you're going to set it equal to 0. So x plus 1 equals 0, x plus 3 equals 0. So we get negative 1 and negative 3. Usually in a story problem, negative values won't work. So always take those, plug it back in to see if it works the problem you're working with. How about this one? Remember we have a quadratic, you need to get everything to one side. So I move the 6x over, it becomes negative. Move this 9 over, it'll become positive. And then go ahead and factor. If the factors are the same, this is called a perfect square. Trinomial, you'll have one result. I don't know if you recall, if you were to graph this, it'll only cross in one spot. That was at 3. Alright, how about this one? I distributed the 3 here, and then I went ahead and distributed the 4, which was silly. Go ahead and add that up, you're going to get 24. Then subtract 12 on both sides, and then divide by 3. Alright, this one looks a little nastier. So I went ahead and distributed the 21. So I had 21x minus 84. And then I had to FOIL this. So 2x squared plus 4x minus 7x minus 14. Combine these two would be negative 3x, but if I subtract the 21 with the negative 3, you're going to get negative 24. And then if I add this 84 here, you're going to get positive 70. So I need to factor this, but notice each one has an even value. So I'm going to factor out of 2. And when I factor out of 2, I'll have 2 times the quantity, x squared minus 12x plus 35. This is a lot easier to factor. What two values multiply get 35, but will add up to give you 12. That would be 7 and 5. Since I need a negative 12, they'll both be negative. So 7 and 5 are my two answers. I like this problem. 10 is multiplied by 10 more than a number. This is 10 more than a number. The product is the square of, okay, so this product is the square of 24. So the square of 24 is 576. I distributed the 10 here. Subtract 100 on both sides, divide by 10. You get a decimal. Don't be afraid of the decimals. Alright, so here comes the fun stuff. Segment of a chord. Okay, so if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. Meaning this, AE times EB is equal CE times ED. Not too bad. You'll remember that one, right? Usually students do. Alright, so let's go ahead and work this out. Find the value of x. Alright, I've got to make sure that this is on the sheet that I printed. I don't think I did. Alright, so I need 15 times x plus 1 is equal to 10 times the quantity x plus 4. So this is why we had a lot of problems like that in our warm-up. Alright, so distribute 15. Distribute the 10. And let's get x's on one side, numbers on the other. So I'm going to subtract 10x on both sides. Then I'm going to subtract 15 on both sides. Divide both sides by 5. Okay, now notice you make sure you look at the directions. It doesn't ask the length of each segment part of the chord. It just asks to find x. Alright, this one. I have x times 4x equals 3x times that quantity x plus 1. So this is 4x squared is equal to, when I distribute this, 3x squared plus 3x. I'm going to subtract the 3x squared on both sides. I have 1x squared is equal to 3x. I want to bring that to the other side here. Remember, if you have quadratics, you usually want to get everything on one side. But factor out an x. Take each factor set equal to 0. So x is equal to 0 and positive 3. What do you think? So far, so good? Next page, we have another theorem here. Theorem 1015. Segments of secants. You ready for this? Okay. If two secant segments share the same endpoint, so like right there, outside the circle, then the product of the lengths of one secant segment and its external segment equals the product of the segments of the other one. Okay, so if we look, EA, that's this part, times the whole thing is equal to EC times that whole thing. Okay, so let's call this X and this Y. We'll call this W and Z. So basically X times Y, so the outside part times the whole thing, is equal to the outside part times the whole thing, ZW. Okay, now that one's not as easy to remember, but still, when we work with it, you'll probably get the hang of it. So let's do 2 examples. Okay, and this is where it gets a little tricky. So remember, we have the outside part times the whole thing. So I have 18 times the whole thing is x plus 18 is equal to the outside part times the whole thing. That whole thing is 40. So I'm going to go ahead and distribute 18x plus 324. 4 times 16 is 64, then add a 0, so 640. Subtract 324 on both sides. And then divide by 18. Alright. It's unusual for a book to give you decimal values, but don't be afraid of them. And please, can someone double check this? Here we go. How about this? The outside part times the whole thing. This whole thing is going to be 14. You ready for this? The outside part, x plus 2, times this whole thing. Now that whole thing is going to be 6x plus 9. So I'm going to have to FOIL this. So 84 is equal to 6x squared. So I have 9x and 12x. Is 21x. And then the last would be plus 18. Subtract 84 on both sides. You get minus 66. Now I need to factor, let's see here, 3 comes out of each one of those. So it's just not going to be a pretty factoring. And I'm just going to help you out there. 2x plus 11, x minus 2. Whenever you have a factoring with that a value, always double check. Alright, so first, 2x times x is 2x squared. Your outer is negative 4x, your inner is positive 11x, that gives you 7x, and then last, negative 22. So here you're going to have x is equal to 2, but this one, if there was no 2 there, it would be negative 11. Then divide by 2. Of course, that's an extraneous answer probably, because you can't have a negative distance. Alright, segments of secants and tangents. I'm in the middle of the video, buddy. I'll help you in a second. If a secant segment and a tangent segment share an endpoint outside, right here, so we have our tangent and the secant, then the products of the lengths of the secant segment and its external segment equals the square of the length of the tangent. Okay, so if I call this x, I call this part y, and call this whole thing z, it's going to be x squared is y times z. Students usually remember that one. Okay, so we're on our last page. Got 4 examples here. And then I'm going to expect you to know all these. So here we go. Alright, so we have a secant and a tangent. So x squared is equal to 24 times that whole thing. The whole thing will be 44. So when I multiply those, you get 1056, and then take the square root. So x is approximately 32.496. How about this one? Another tangent with secants. So you can take the 24 squared is equal to 16 times that whole thing. That's 16 plus x. So I'm going to distribute the 16, and 24 squared is 576. 16 times 16 is 256, plus 16x. Subtract the 256 on both sides. Divide by 16. X is equal to 20. Okay, this problem. We have to square that. We have a tangent and a secant. So the quantity x plus 3 squared, be careful, we're going to have to FOIL that, is equal to the outside part, 2x minus 2 times the whole thing. That whole thing is going to be 3x, and what do the 2's do? They cancel. Alright, so when I FOIL this, I have x squared plus 6x plus 9 is equal to, go ahead and distribute, 6x squared minus 6x. Now, I'm going to bring everything to this side, just because that 6x squared is larger. And remember, when you want to solve quadratic, you need everything to one side, 0 on the other. So 6x squared minus 1x squared is 5x squared, minus, we'll end up with 12x minus 9. And I'll help you out factoring this. You have 5x plus 3, and x minus 3. So your solutions will be negative 3/5 and 3. This is probably going to be the one you want. Okay. And last but not least, notice how this did say x and y if needed. So that's what I have here. Got a lot going on here. Okay. Going back to your interior, 4 times 9 is equal to 12 times y. Four times 9 is 36, is equal to 12y, divide by 12, y is equal to 3. So I know this is 3. Alright, so now I have a tangent and a secant. So square the tangent, you have 18 squared, is equal to the outside part, which is x, times the whole thing, x plus 15. So 18 squared is 324. I'll go ahead and distribute. So bring that 324 to the other side. And factor. So again, it's not a pretty factor because the numbers are so large, but this one actually factors nicely. X plus 27 and x minus 12. So x is equal to negative 27. And it's probably not going to be the answer because it's extraneous. And positive 12. Can you see that? Oh, you couldn't see any of that. Alright, so take a good look at that. Hopefully you were able to work that out. Here's our homework, and there's our Common Core standard. So have a very nice day. Take care of yourselves.